going to be about homework number 9, the last homework. It was quite hard, but very important, so it's important that you understand it. Now, the first question was about S4 and cycle types in S4 and the class equation in S4. Now, most people, I went over cycle types in the last video, so I won't do that again, but most people did this right and got the class equation to be 1 plus 3 plus 6 plus 6 plus 8 equals 24. So these are the sizes of the different conjugacy classes in S4. You count the number of cycles of each type. Now, most people also managed to work out that the even permutations came from the 1, the 3, and the 8. So the even permutations came from the 1, the 3, and the 8. But we better go through this because some people have trouble with this. So the different cycle types in S4, there's 4, 3, 1, 2, 2, 2, 1, 1, and 1, 1, 1, 1. And a typical element here is 1, 2, 3, 4. A typical element here is 1, 2, 3, 1, 2, 3, 4, 1, 2, and this one's just the identity. So if you write these out as transpositions, whoops, that's a typical way of writing this one as transpositions. That's a typical way of writing this one as transpositions. This one is already a transposition, so is this one. And this one, the identity is the product of 0 transpositions. So if you look at this carefully, this one is odd, this one is even, this one is even, this one is odd because that's only one transposition. The identity is always even. And so the number of ones like this is 8, and the number of ones like this is 3. So this gives 8. This one gave 3, and this one gave 1. But that can't be the class equation for A4. So this is what the even ones make A4. But this can't be the class equation because how many permutations, even permutations, are there? So some people deduced not correctly which ones were even, and then added them up and got something that wasn't the right number of permutations. So if you're counting the number of even permutations, you know that the number of even permutations has to be 24 divided by 2, because it's exactly half of all the permutations. So that has to equal 12. So these do add up to 12, but 1 plus 3 plus 8 equals 12 can't be the class equation because 8 doesn't divide 12. So we know that 8, although it's the size of the conjugacy class in S4, it can't be the size of the conjugacy class in A4. So that's what that was about. Now, the next thing that we were asked to do is to see what other normal subgroups there could possibly be. So remember that we can use the class equation to tell if a subgroup is normal because it'll be a union of conjugacy classes. So suppose H is a normal subgroup of S4. Then we know that just to be a subgroup at all, the order of H is going to have to divide 24. But to be normal, that's just to be a subgroup. But to be normal, we've got to have the order of H is a sum of some of these numbers, 1, 3, 6, 6, and 8, to be normal. And you can try all possible combinations, and the only way that you can get a factor of 24 by adding these numbers together is to do 1 plus 3. So the only way is 1 plus 3 equals 4. Now, the next thing you have to do is to see whether this really is a subgroup, because this only tells you that if it was a normal subgroup, then it would certainly have to consist of this conjugacy class plus that one. So now you have to see whether that really is a subgroup or not. And so you have to look at those two conjugacy classes and see what the elements are in them. Now I've rubbed it off now, but the conjugacy class of size 3 was the one that had elements of this type, of cycle type 2, 2. So those are the ones that would form this normal subgroup if it were a subgroup. So the conjugacy class of size 1, so we're looking at 1 and 3, the conjugacy class of size 1 is just the one with the identity in it, and the conjugacy class of size 3 has all the elements of cycle type 2, 2. So that's 1, 2, 3, 4, 1, 3, 2, 4, and 1, 4, 2, 3. So you've got to look at this collection of things and see whether they form a subgroup. So to show that they form a subgroup, you have to show that they're closed under multiplication, that they've got the identity in there, and that they've all got inverses. So they've certainly got the identity in there. They've all got inverses, because all of these things are inverse to themselves. So the thing you then have to check is that they're closed under multiplication. That involves multiplying any one of these by any other one of these, and showing that the result is another one of these. So once you've done that, you've shown that these elements really do form a subgroup, and because they're a union of conjugacy classes, you know that they must be a normal subgroup, and that they are the only other possible normal subgroup of S4 apart from A4. So that's the end of, I think, yes, that's the end of question 1.